All right, I've been making head trackers for years, and since VR is definitely a thing now, I don't think I'm gonna ever sell as many as I used to, but I used to do at least a couple to a few a month. And so this is a video to just outline that process, how a head tracker for flight sims or other stuff is actually made. So I'm trying to get an old USB cable here right now, actually, and prepare it so we can use it. It's got some sticky stuff on the bottom. Anyways, got my soldering iron, it's heating up right now. We're gonna strip some wire, and then we will solder the LEDs and a small resistor. Sorry, I'm just trying to clean up a little bit. Home Depot sells these wire strippers. They are my absolute favorite. Again, I haven't put them through heavy use, but generally they work really well for most things in the house. Small electronics, that is, to solder. So we got solder, we got electrical tape, and my daughter's here. She's talking to my cat. So we got solder here. We got... Okay, Chloe. This is a stand. I kind of want to use that. We're going to use some wire that I like. It's kind of thin, which is nice. Maybe we can bend it and move it around. Some steel wool, which really comes in handy. We got our LEDs. We got, there's the wire. This is some kind of old stuff I found. It's kind of neat. It's in one of these old metal spools. I think I got it at a yard sale or something. Anyways, I make each length maybe about 10 inches. That gives you a lot of flexibility with how you attach it to a hat. So we're going to do 4 lengths of this. The camera I have here, this is a PS3i. It has a screen mount, so it'll like sit on top of a screen. This kind of thing will kind of create some pressure. What do you want?
I do have the lunches.
The lunches?
No.
Oh, the wrenches. Yeah.
The
little wrenches. There you go.
Thanks.
My daughter loves tools.
Fake.
Okay, so we're gonna get these. That's 1, 2, that's 3. Let's get a 4th one. About the same length. Excellent. Okay, so now what we're going to do is we're going to strip all the ends of these, probably 3/4 to maybe half an inch is probably plenty. Use the smallest one. Again, I like the thinner wire, it just doesn't take up so much room. And it's not as rigid. It's much more easy to kind of bend and move around. This is kind of the general shape of what a lot of head tracker things that people like to use. I don't cut mine necessarily to fit that. I cut mine probably for a hat. But if you want to put it on here, I mean, worst case, you like, you know, glue this down, maybe double up some of your wire or whatever to get it all to kind of come out the same spot. That's fine. I've had people ask me if I'll cut it to specific lengths, and no problem. It's really easy. Saves actually a bit of wire. So, the LEDs I'm using are wide aperture, meaning that they will be seen. Like if you were to replace a LED in your infrared portion of your, it's called, gosh, your IR remote for, you know, like a TV or something. Depending on the aperture of the actual LED, that determines how easy it is for you to point it at the TV or have it at different angles and for the TV to see it. So these LEDs have like, gosh, they're like 60 degree or maybe even more, 78, I can't remember, it had a kind of a funny number. But they're good, meaning that they don't draw a lot of power, but they've got a wide aperture, meaning the sensor or this camera, it will be able to see these LEDs moving around even when your head is tilted, you know, at kind of further angles. So that's why I go with these ones. Okay. Same with these. These are really special, expensive ones. I think I used to sell different USB 3 and USB 2.0 kits, but I really don't. You know, it's. I mean, sometimes you think the electronics, you don't want to damage somebody's CPU. So this is what I'm building is basically USB 3.0 compatible. It will work in a 2.0, but this is fine. Okay, now I have two of my kids out here, so it's going to get loud. I'm recording something, Reed. Are you okay? You'll want to use a calculator to know what the resistor is that you should use on your assembly. Sorry, we're not going to put that on there yet. Okay, one thing about LEDs, at least these kind, and pretty much every single one I've ever worked with, these are through-hole LEDs, so they've got like a long post. And one thing you're going to notice if you look at them really close is they do have one prong that is longer than the other. And if you were to look inside this, it's very dark, whatever color material they put on there. They are not the same. The prongs don't go in there and look the same. There is a right and a left side, meaning that one side goes in and then the electricity comes out the other and goes that way through the series of your other LEDs. So what you want to make sure that you do is that you solder them in the same pattern. Long, short, long, short, long, short. If you don't, if you have one switched, the whole series won't work. It's going to stop the flow of the electrons or whatever. It just doesn't carry the current the same way, and it won't work. So as you're soldering them, make sure that you're long, short, long, short, long, short, or short, long, short, long. And then before you solder everything at the end, you'll just do a test. You'll plug it in and see. Okay, so I usually just start wrapping the long ones. And so what I do is I give them a really gentle tug to kind of spread the through-hole prongs apart a little bit. I'm going to take one of these wire ends and I'm going to just kind of get it as twisted up close to the top as I can. Sometimes you have to spread these a little bit more and then we'll kind of twist them down here and then we'll slide them kind of up close, but not, like on top of that thing, but we're gonna clip this eventually. Okay, so that's a long end right there. That's one. Okay. All right, let's go like this. Again, I have used a calculator to make sure that these are all good to go. I had the spec sheet for these. I can't remember. I think I got them from Mauser.com or Mauser Electronics or whatever that distribution is for small electronic parts like buttons and resistors and all kinds of different stuff. A lot of my... Gosh, I don't even know if they're in business anymore. And after this thing, the pandemic, I don't even know if Radio Shack is going to be around ever again. That was a pretty handy store, and when they were going out of business, I bought a bunch of their resistors and other things that I was using. So I think a 33 ohm, or I don't know, I think 47 to 33 or 10. I think I use a 10 on some of these other ones. I'm going to use a 33. Just that's kind of moderate. I mean, again, these are 1.5 volt LEDs. They're pretty light. Careful, Reed. That's hot. Can you back up, bud? Can you back up, please? This is super hot. I need you to back up. Okay. I'm not a great solderer, but how I usually do it... I don't think I have a clip anymore. I used to have a clamp that would hold it. I'll use this guy. Can you back up, please? I'd like you to back up, please. So what I do is I'll just gently touch kind of part of the silver of the wire there, and then just kind of let this solder kind of bleed onto it. I might need to clean this. That's what the steel wool is for, just kind of wipe off excess old solder. And I'm going to wreck this towel. My wife is going to be thrilled. That. Get these other ones away. Now the other thing too you got to be really cognizant of is some LEDs are very sensitive, and if you get them too hot, it will wreck them. So you can't, be fiddling around trying to solder it forever. Man, I am not getting that solder to jump on there. Usually, if you just kind of touch it to there, the solder will just kind of jump off and get on the wire, no problem. But this one is not. There we go. That LED might be botched. Gosh, I had to touch that one a lot. So again, we're trying to just touch and get a little, just a bit of that solder on there. We don't need a ton, but we want a quality product. We want it to last. Come on. There we go. Straighten this out. Be super careful with your soldering iron too. I mean, they just get crazy hot. They'll burn the heck out of you. And if you can, avoid leaving any little barbs on there. I'll show you a step that we're going to take at the end to get just some electrical tape there to cover them up. You can use shrink wrapping or shrink tubing, whatever that stuff is. I've used it before. It's just another step. You have to, it's just a hassle to have to cut that stuff up, and I know I'm lazy. Whatever. Okay, here is our USB cable. Black is negative, red is positive. I don't know. I usually just... I might need to cut this some more. I don't know. This is like a really stumpy little short thing here. If I can pull some more wire out.
Maybe you need to cut the black one.
Maybe cut the black one. I kind of like this longer, but if I can just get a little bit more exposure there. And then we're going to wrap the resistor. I tend to put the resistor first. I don't know, it just helps me think about the series and what I'm doing. It doesn't really matter if it's at the black or the red, as long as it's all in the system. Okay, we're going to solder that guy on there. So same process, we just wrap the wire on it. There we go. Okay, we can clean this up and nip off that little end there. Don't cut your wire. Okay. And then I'll show you another trick at the end. We're going to use some excess tubing from another USB cord that I had like this. I stripped. I took all of the tubing, and then I used that as casing. I'm going to wrap this part in electrical tape separate from this, and we're going to just put all this in tubing and wrap it in electrical just to keep it kind of covered and nice, and then that way it's safe. You want to keep all these different exposed wires kind of partitioned from each other. It's not getting hot yet. Huh. Thought that thing would be blazing hot. Ooh, that almost dripped. That was a lot of solder right there too. Holy cow. Yeah, I have another mount that it just kind of clamps it and holds it like this, and it's perfect because it's pointing down, and the solder doesn't tend to jump up to it. It likes to drip onto it and down on the underside, and that's a huge pain. I should get that thing out, but I just don't know where it is right now. I could rig this thing up to hold it, couldn't I? That's too little, too light. Okay, so what we want to do now that we know that these are all soldered onto the long ends, we're going to go ahead and connect the small, shorter posts. And then we're going to do just a quick test. We're going to plug our thing in, and we're going to make sure that the LEDs do light up. And these ones you can barely see with the naked eye. Some others you cannot see at all. I don't know if that's just the particular wavelength of the infrared. I know infrared is a bandwidth, or there is a small portion of the spectrum that is infrared, but these ones you can just barely see. And the way that you do check that is that you're going to use you could use your cell phone camera, and more often than not, that will allow you to see infrared light. So now what I'm doing is I'm just gonna string these up. Okay, and I'm gonna go ahead and solder them. I'm feeling gutsy. Okay, get this pushed up there. That's a camera. Yep. That's a PlayStation 3i camera is what they call it. Or yeah, excuse me, PS3i. Like eyeball. We like the PS3i. There is a driver out there, or there's probably a couple different sources, so that your computer can then interface with it and you can use it with head tracking software. PS3i is good because you can modify it. I will say this, there are two different, at least that I know of, there are two different models of the PS3i as far as the internal design. And you want the one that has the concave or kind of curved outer lens. If it's flat, you will not be able to modify it because the infrared filter is nestled inside of it or between a couple of other lenses, and you will wreck it trying to modify it. I've tried it, and I found the thing at a thrift store for a couple bucks and thought, yeah, I could do this. Come on, people are wusses. And totally destroyed the thing. PS3i that has a concave outer lens is good to go. Flat outer lens will not work. Okay, so now I gotta be careful. I don't wanna like get my wires all crossed up here. And I'm just gonna, again, push these up here, not super high, but let's keep things tidy. I'll put my solder down low and see if it'll drip onto this. Again, we don't want to touch the soldering iron to that too long because it heats stuff up really hot and you'll wreck your LED. So if you are going to do this on your own, I recommend getting at least a couple extras. Gosh darn it. Just kind of wipe it on there. There we go. I wonder if you could just glue it, if there's some kind of resin that you could just kind of, if you're not comfortable soldering or wanting to go buy a soldering iron and all this other nonsense, I bet there's ways you could just kind of get around this. Soldering's good. It's much more firm. It keeps the conductivity up. It's a good skill to know. You can repair small electronics, and I just did a buddy's clock the other week. It's kind of fun. It's a good thing to know. Okay, we're at the point now where we've soldered everything up except the wires to the USB thing. Hey Reed, can you go inside and can you get the white plug that this goes into for a wall so it'll plug into here? Could you go get it? I think I left it in the girls' bathroom. We were testing one. You built one last night for somebody. Thank you. I really appreciate your help. Okay. And I'm gonna, that could have been a really bad move. Careful where this thing is. I'm not focused right now, so I'm gonna not ruin this towel and save my marriage and go ahead and get this out of the way. Hey, we got our cord ready. Just set this kind of off to the side and made a nice burn mark in my table the other day from just working on something else. What we're going to do then is we're going to just choose either end. I don't remember if it's the long end or the short end of the posts. And we're going to wire this in. Thank you, Reed. I appreciate that. So we're going to try this just with a wall plug. So we plug it in right here. If any of these things are crisscrossed or if any of the other exposed wires are touching, that's why I kind of split the LED posts a little bit so they're not going to touch each other. We're going to look now, and I can see light in those two, just a faint little thing. And if we look in the camera, there it is. First try. So now we have 3 LEDs, and look at that. See the angle at which you can still see that? I'll get over here where it's kind of dim. That's almost 90 degrees from the camera. Good, that's a good LED. Okay, so we're gonna go ahead and unplug this now. We're gonna solder up the resistor to the other end, and then the hot end, the negative end, and finish the soldering part, and then we can safely, get melted that. We can then start our casing process to seal everything up and kind of protect it a little bit. So we need our solder. Let's go ahead and we'll pull this guy right there. We'll touch it. The resistors are much more hardy, and if you don't need to drench it in solder, but whatever. You don't need to be as delicate. So let's get this guy too. Just kind of wipe it on there. There you go. Oh, I got hot. Okay. go ahead and clip off this other end of the resistor so it's not nearly as long. I mean, you can be as, I don't know, I like to just kind of clean things up a little bit. Okay, and now for the LEDs, and we'll unplug the soldering iron, put her away over here. Oops, don't drip on my table, please. I need to get a better soldering iron, one that you can kind of control the temperature on, and you could work with other electronics much more efficiently and safely because you're not going to overheat them or break them. There was a mouse I really wanted to work on, and I think it got too hot and it fried part of the board for a button that I was trying to replace on it. So what we're doing now is we're clipping off the excess posts. Nip that off. There we go. So again, through-hole LEDs. I can't remember the other kind, but they sit much more flat, and they might have really little shallow prongs that are soldered onto little boards in some way or another. But through-hole is going to be probably the easiest design or type that you're going to want to use. You're going to, and before you buy the type that you want, maybe I'll try and find a link and I can put it in the video here for the kind I found. You're definitely going to want to use a calculator to, just make sure that your resistor is appropriate and that your LEDs are going to work in that series. There's calculators out there, no problem, that you can find. I think on one of the websites that talks about head tracking stuff, they even had a really good calculator there for people to use. So, you'll use what power source? Okay, I'm using a 9-volt battery. That would be using a different, like a plug like this, and here's your ends that you would solder. Or you could have a battery pack. What is the total amount of energy that's going to be supplied by, what is this? 4 AAA batteries. So if you want to use rechargeable batteries instead of having a cord dangling around, you'd look at how much that's going to supply. AA's, whatever. And the USB cable, you can use USB 3.0, USB 2.0 slot, and you'll then decide what is going to be the most appropriate for your needs and make your calculations there, and that will determine the resistor that you're going to put in there. Again, it'll probably be just tens of ohms. I don't think it's, depending on the source, unless you get like a wall plug, that would be kind of extreme, but I'll try and cut this one in half. Okay, here's some of the excess tubing or just kind of wire casing. I pulled this off another cord, and I'm gonna split it like this and not cut my finger wide open. And we're just gonna open it up. Okay. Just like that. And now what we're going to do, well, first, before we do that, I'd like to just put one little bit of electrical right here to just keep this portion separate from the positive end. Okay, so then that's separate. This got a little bit of barb kind of stuff on it. I'm going to see if I can kind of smash it down so it's not so spiky. I just don't want it to pierce anything. Not that it's going to see a lot of action. Okay. And then we're going to lay these guys in there. So now they're insulated and covered up. We're going to give them their own. The other thing too, in some of these there's going to be loose casing, so there's this kind of fine, I'm going to slide this up. There's this fine wire down here, and I don't like it because I don't know, it's just something that could kind of short your connection a little bit. And so let's cover up this little soldered end right here from all of that. So put it down way low. I can't remember how long ago I had this wire prepared, but it's been a long time and I haven't looked at it, so maybe I just took a pass on this one and I wasn't being careful. Okay, there we go. Slide this back down. Put your resistor, negative and positive ends, and then obviously things need to kind of split. So this is, this also gives it a little bit of rigidity down here to protect the resistor, just so things don't wear and bend and do all that nonsense that wears them out and will eventually break it. Worst case, you just, cut it off and use those parts, resolder. It's, no big deal. It's not going to matter if it's, come on, seriously. Okay. And we're going to wire this, or excuse me, seal this up and make it look very nice. There we go. Again, this is one of those areas that you can use the shrink tubing. I've used it a couple times. It's just another step, to cut it up, measure it, or whatever you want to do. And then you need what's most appropriate is like a heat gun. I guess you could use like a hair dryer. I'm not sure if those get hot enough, but the heat gun, you just kind of like point at it and wave it over it, whatever, and it'll shrink the tubing and kind of constrict it around your wiring and really clean things up nice. I like it. Again, I just never sprang to buy the heat gun. I did it actually with my soldering iron, where I would just kind of like barely rub it or touch it on there, and it would shrink it up kind of nice. But I didn't like the whole extra step of having to cut stuff up. I just I know, just didn't. But it would make these look really nice. But still, you want these ends to be separate. So here's how I do that. You want to cover these up and make them look nice. So what I do is I put the electrical tape between them, and I wrap one side pretty good, so it's not going to be contacted or touched by the other wire or the other side. And then I just kind of hold them, so they're a little bit apart. I don't know if you can see that. There we go. And then I just fold that excess right there, and I try not to cover up the lens in any way, or the end of the LED. And then I just make a little, just a little tab of tape right there. So it's covered up, but the two ends are still separate. And we're obviously going to do another test before we finish up. 2 more of these, that'll do it. I was talking about the PS3i. Again, that's a really good one, a common one. I think it has a 60 frames per second capability, like just built in. So it's a decent camera. And I think there's just a lot of them out there. So if you can find one on eBay for a few bucks, I really don't think that people are flocking to, pick up. Gosh, how old is the PS3? I don't know, like 8 years old. I have no idea. You could probably find one for pretty cheap. Keep an eye out for those things in thrift stores, and again, just watch out for that lens design. That's what'll get you. Did I tangle these? Okay, so anyways, the design that we made here, this kind of triple junction of LEDs is versatile in that you can put it on the side of your headset in any kind of configuration you want. That's popular, or you can put it on a hat. I think people use like binder clip type things to just kind of mount it nice. And those are the designs I've seen. People 3D print that kind of funky, that piece of wood that I had, that they'll 3D print this kind of thing so that it can go on the side of your headphones. And this keeps the LEDs at different, they kind of need to be in different lengths so the computer can tell, oh, this is the closest one, furthest one, kind of medium distance. And so as this is kind of like moving around in space or looking at the camera, and the lights are shining at the camera, it's able to determine with its code, basically, what does that translate to into 3D space? How is this head movement going to translate into head movement in the cockpit or driver's seat of whatever it is that you're using? So that's why they're kind of spaced like that. And actually on a hat, I think you can, 2 of them can be the same, distance apart, but your third one has to be, so it's going to be 2 at the same length like this, and then on the top of your hat kind of recessed back further towards the top of your head. So 2 like this, and then 1, up here by itself. So, okay, let's do one final test. We've wired everything up. I think everything looks good. Try not to work on these things as they're plugged in. Just, you don't want to electrocute yourself or, be messing with those wires. Okay, so let's bring it up close. There we go. We see infrared light in the camera at all angles. Kind of move them around. I like to just, check the wires, make sure that they're firm. If things start flickering or going off and on, then that means maybe the soldering's bad or some little bit of the wire is touching another one. But that right there is, that's a positive, good test on those 3 lights. Yep, and that is how you make an infrared head tracking array. So now the next step is attaching it to your hat or your headphones or whatever it is that you're going to use to mount. And then you are going to go through the process of setting up the camera to interface with your computer and begin the calibration or whatever it is that, whatever that software, Free Track IR, Free Track something. There's so many different, there's a couple different programs I know out there for this. And those are the ones that, that's what you're going to do then, is start going through that process of calibrating or, adjusting it in sensitivities to interpret your head movement into the cockpit or the driver's seat. Okay? Part-wise, these are maybe 40 to 50 cents to $1 each. A little bit of wire, a little bit of solder, a resistor. You buy them in packs for a couple bucks or something. And a decent length cord. So that's how it's done. I'll leave some links. I'll try to. Again, this is a dying business for me. Not that it was like really a business. It was just kind of a fun hobby. But I've sold a few tens of these. I've made a lot, and I think ever since VR came out, my sales have really gone down. Not to say that flight simulators are really like that popular to begin with, but things are changing, and this is a very economical and still, can be pretty rewarding way to enjoy flight sims or car, like racing games, stuff like that. If you're not diehard, but VR does take a bit more horsepower for your computer to run. The actual peripherals themselves are going to be hundreds of dollars. It's there's a difference in experience, but cost up front to even get into it. I find this to be good. Not amazing, but it is good. A lot of people were very satisfied with this setup and this method for years. I can't remember when the first IR stuff, but it's been probably 5 or 6 years we've seen this kind of thing around. So this is a good setup. This is a good way to go. Leave questions, comment, like, subscribe, whatever. Thanks.